Hello, today we will be focusing our lecture on the design of eccentric connections with load lying in the plane of joint. Now, this joint will be connected using rivet as well as bolt. That means, first we will see how to calculate the resultant force on a particular rivet with the orientation of a joint like this, and then how to find out the number of rivets and what will be the configuration of those rivet joints. Then we will see the same problem with the bolt joint. Means in case of bolt joint we know that it is almost the calculations are similar to the rivet joints. Only difference is the gross diameter and nominal diameter. In case of rivet joint we use gross diameter, and in case of bolt joint we will use the diameter of the bolt, not the gross diameter. So, this difference will be there. So, the way we have designed in case of direct axial forces while coming into picture, the bolt we have designed. So, in similar way we will design here also for the bolted connections. So, we will see those things, and our focus of lecture today will be only on load lying in plane of joint. Means in plane of joint how to design, how to analyze, all those things we will discuss in details. Now, first when we are going to design a riveted joint, we have to know what is the number of rivet. Now, number of rivets can be decided in either from this equation that n is equal to p by r, where p is the load which is coming into picture and r is the rivet value, or from this equation that n is equal to root over 6 m by m p r, where m is the moment and on that basis. Now, in general from our experience it is seen that we can use this equation if load is very high compared to the moment, and in that case we can find out the number of rivets by increasing 25%, and in that way we can make it, because we know the for a particular rivet direct load is coming and another the load due to moment is coming. So, the resultant whatever it is coming, it is more than the any of these two. That is why we have to choose the number of rivet in such a way that the value is coming less compared to the expected value. So, in that way we can make the number, and if moment is more compared to the load, then that also it depends on the designer's experience, some extra number we can increase. So, with this in mind, say let us design a bracket joint, then let us see how we are increasing and how it is working, we will be getting to know. So, let us go through one example. So, this is an example, say one bracketed connection has to made which will pass the load to the column, and the rivet joint has to made in such a way that it without failure it can pass this much load. Say P is equal to is given 225 kilonewton, and the eccentricity is this one, this is say 160 mm, eccentricity is given, right. Now, with this we have to design the connections. Now, let us assume some diameter of rivets, because on that basis I have to find out the rivet value. Say diameter of the rivet, say 20 mm diameter of power driven soft rivet we have used. So, with this we have to make. So, now we have to find out the rivet value. For this, what is the rivet value? Rivet value we know tau Vf into pi by 4 into d square. So, that means 100 into pi by 4. This 100 value is coming because of power driven soft rivet which is given in the codal provisions, and d is 20 mm. So, gross diameter will become 21.5 mm. So, after multiplying this we will get 36.3 into 10 cube Newton, that means 36.3 kilonewton. So, rivet value is 36.3 kilonewton. So, in this way we can find out the rivet value. Now, we can find out the value of the number of rivet from the load point of view. Number of rivet I can find out, say 25% if I make extra, 1.25 into P by R, right. So, this will become 1.25 into P is 225 kilonewton and R is 36.3 kilonewton. So, this is coming around say 7.8, that means 8. That means from load point of view we can use 8 numbers of rivet with 20 mm diameter, power driven soft rivet. 8 numbers means if we use in 2 row, then 2 row with 4 numbers of rivet, means 4 numbers of rivet in each row we can provide, then we can make it. So, from load point of view we can find out this much number. Now, let us see from the moment point of view. From moment point of view, how do I find out the number? We know the equation, that is 6 m by m into P into R, where moment is P into E, P is 225 into E means 160 mm, that means 0.16. Okay. So, this is kilonewton, this is meter. So, m, let us assume that in 2 rows the rivet has been distributed. So, 2, and let us assume the say pitch at say 60 mm, that means 0.06 mm into R, R is 36.3 kilonewton. So, from this I can find out the number of rivet. So, this is coming around 7.5, that means say around 8. That means from this moment consideration the number of rivets will be required 8 into 2, that means 2 rows with 8 numbers of 25 PDS, power driven soft rivet. So, in this way the number is becoming 16. So, from moment point of view we are getting 16, from load point of view we are getting 8. So, finally, we will assume that we are using this much, because moment has to withstand by the joint. Now, this 60 mm has been considered from here. So, if we see, this is the 60 mm, right. So, in this way we have calculated. Now, let us go the detailing of this. So, 16 rivets are placed in 2 rows. So, 8 rivets are placed in 1 row. So, let us place and let us find out the details of those. So, these are the pitch distance, so pitch distance can be find out from the codal provision, that is 2.5 d around we can make. So, this is becoming 50. So, let us the pitch distance is 50. So, and this distance we have made 60, right. So, the neutral axis will be passing through this. So, this is 25, it should be 25, again 50, 50, 50. So, the largest amount of load will be exerted on the outermost rivet, either here or here, because from the last class we have seen why it will be the largest, because the FA will be at the downward and this will be the 90 degree with this radius, this is Fn, and other rivets it will be less. So, this rivet will be the critical rivet, either this one or this one. So, we will calculate the force exerted on these rivets and then we will see whether it is exceeding the rivet value or not, and accordingly we will check the design. So, for calculating all these things we have to know R1, R2, R3. So, let us find out R1. R1 means this one will be root over 60 square plus 25 square, that means this will be 5 square. So, this will become 65. Similarly, R2 will become, this will become 25 plus 50, that means 75, that means 60 square plus 75 square. So, this is coming around 96.05 mm. Similarly, R3 will become this will become again 50, that means 125 plus 60 square. So, this is coming 138.65 mm. Similarly, R 4 will be 175 plus 60 square is equal to 185 mm. So, this distance we are getting, this is 65, this is 96.05, this is 138.65 and this is becoming 185 mm. So, in this way we can find out all these distances. Now, summation r square we have to make, because we know the force developed due to this moment is nothing but m r by summation r square. So, summation r square, let us find out, this will become 4 into r 1 square plus r 2 square plus r 3 square plus r 4 square. So, this will become totally 4, because similar type of things, this means one row if we consider from here, then into 4 it will be. So, 4 into this r 1 square plus r 2 square plus r 3 square plus r 4 square. So, this will become, after calculation of this, we will get 267,598 millimeter square, and the maximum force will develop at the outermost either of this one or this one. So, F m will become, m is nothing but 36, which we have calculated, kilonewton meter, that means in Newton millimeter if we make 36 into 10 to the power 6 into r, r will nothing but r 4, this will be, that means outermost rivet, 185 its distance, and summation r square is 267,598. So, after calculating all this, we will get the value as 24.9 kilonewton, right. So, force exerted on the outermost rivet due to moment is 24.9 kilonewton meter. This is one force. Another force is due to the direct load, that is direct load was applied 225 kilonewton and total rivet is 2 into 8 means 16 rivets. So, this is coming 14.06 kilonewton. So, one is, this is F A and this is F N, right. Now, we have to find out the angle between these two, we have to find out. Now, theta can be find out from this, if we see theta will be nothing but this one, from which we can find out. So, theta will be tan inverse 175 by 60, because outermost rivet vertical distance is 175 and this horizontal distance is 60. So, theta will be tan inverse 175 by 60, that is coming 71 degree. So, resultant force F r can be find out from this equation, that is F a square plus F m square plus 2 F a F m cos theta. So, from this we will get the value, that is 14.06 square, F m is 24.9 plus 2 into 14.06 into 24.9 into cos 71. So, after calculating this value, we are getting F r as 32.3 kilonewton. So, resultant force is coming 32.3 kilonewton. This is the maximum force exerted on the rivet, which is less than the rivet value. Rivet value is 36.3 kilonewton for this particular diameter of rivet. So, this is okay, that means the joint is safe. That means the configuration whatever we have made, the number of rivets whatever we have assumed or we have calculated is safe to carry that much load, that means 225 kilonewton load of 160 mm distance from the center of the rivet joints can be carried by the rivet with those configuration. So, finally, what the design will be, because the designer will see only the design, how the design has been done, what are the drawing says, and accordingly the person who is executing in the construction site, they will make the things. So, the design details will be like this. This is the bracket, this load is here. Now, this is the CG, so in this way it has been 1, 2, 3, 4, 5, 6, 7. Okay. So, 8 rivets in each group. So, this is a edge distance, let us consider say 40, and these are 50, and this is 120, then 60 into 60, and say this is take as 40. So, we are assuming edge distance as 40. So, this total depth of this will become 7 into 50 plus 2 into 40, that means 430 mm this total distance, and this will become say total, at least this has to become 120 plus 2 into 80, that means 200. So, this will be 200, and this numbers will be 8 numbers 25 power driven soft rivet has been used, total 8 number in each row. So, the configuration of the joint will be like this. So, in this way we can make it, which can carry the load of 225 kilonewton with an eccentricity of 160 mm. Now, just let me overview that what I have done. First, we have find out the moment, what is the moment we have, then the rivet value considering a particular diameter of rivet has been used, and accordingly the pitch has been decided as 2.5 D, that means 50 mm, and accordingly we can find out the total number of rivet required, that is coming around 8. From this, that means 8 number of rivets is required for from load point of view, and from moment point of view it is required 8 number of rivets with 2 rows. So, finally, we are providing 2 rows and 16 number of rivets totally, and according to that the R1, R2 value, R3 value and R4 value can be found out, and summation R square can be made. So, from those formula the Fm is we know that Mr by summation M R square. So, from this I can find out the force exerted in the extreme rivet, that is this much, and axial force is 14.06 in each rivet, and the theta between these two force will become 71 degree, and resultant force can be made from this equation, which is coming 32.3 kilonewton, which is less than 36.3, which is the rivet value. So, this is okay, means the design is safe to carry the given load, which is 225 kilonewton with a distance of 160 mm. Now, we will go through another example, how to calculate and how to find out the allowable load of a particular joint. Joint is given in different way, 3 type of rivets has been used. So, let us see through this picture we will be able to understand. So, there are 4 rivets in each row. So, these are the rivets have been given again so this is another plate and a gantry girder is carrying the load. This is P with an eccentricity of, say this is 250 mm. So, eccentricity is 250 mm. Now, with this configuration we have to find out the permissible value of P. That means, here 4 number of rivets in each row has been provided to connect this joint, and here with this plate 4 rivets has been made to connect this gantry girder, and gantry girder is connected in this way. So, 3 number of rivets, right, and this eccentricity here is 50 mm. This is the eccentricity, and the distance between this has been given, that is edge distance is 50 and pitch distance is 60. This is given, and here it is edge distance is 40 and pitch is 50. Right. So, these are the details of the joint. Now, we have to find out, say find out maximum permissible load, the joint can carry. Use 20 mm phi diameter, means 20 mm diameter of power driven sub rivet. So, you have to find out the maximum permissible load using 20 mm diameter of power driven sub rivet with this configuration of the joint. First, we will see what is the rivet value. Rivet value in single shear will be tau Vf into pi by 4 into d square, that means 100 into pi by 4 into 21.5, because 20 is the rivet diameter. So, this is becoming 36.3 kilonewton in single shear. In double shear, the rivet value will be 36.3 into 2, 72.6 kilonewton, right. Now, let us come through one by one connections. First, we will see connection between girder and the angle, So, this is one, we will see from this point of view what will be the load carrying capacity, then we will go to this line, then we will go to this one. So, first let us see connection between girder and angle. Here 3 rivets have been used in the girder, 3 rivets in each. So, if 2 angles are used, then let us assume that 2 angles have been used to connect this. So, 2 into 3, 6 rivets have been used. So, total number of rivets will become 2 into 3, that is 6. So, permissible load, say P1 will become 6 into 36 point, means 6 into rivet value, that means 6 into 36.3, that is 217.8 kilonewton. So, this is the permissible value of the load which can carry by this connection, the connection between girder and the angle. So, the permissible load P1 become 217.8 kilonewton, right. This is from this point of view we can make. Another is the connection between angle and bracket. connection between angle and bracket. So, if we see the connection between angle and bracket, these two angles are connected to the bracket through 4 rivets, and each rivets are in double shear because of two angles are located, and the eccentricity is 50 mm. The load is acting here and we have to make connections here. So, 50 mm eccentricity is there. So, moment is there as well as the direct load is there. So, for that we have to make accordingly. So, first is moment due to eccentricity will become P into E. That means, if I use the P2 as a value, permissible value, P2 into E, E is becoming 0.05 meter. Okay. So, this will be the value, and maximum force will be carried by the outermost rivet. That means, that is P2 E R by summation R square. That will be the maximum force at the outermost rivet. Outermost rivet means this one. If I see from this, so this will be the outermost rivet. That means 25 plus 50, 75 millimeter distance away from the CG. So, this we have to find out. So, let us first find out summation R square, because then we can make the values. Summation R square means this will become 2 into 25 square, the first one, and then 50 plus 25 square. So, this will become summation R square. These values are coming 2 into 6250 millimeter square, and R will become the outermost, that means 50 plus 25, that means 75 millimeter. So, I can find out this value as P2 into E means 0.05 into R means 75 millimeter, that means 0.075 by summation R square, that means 6250, this is millimeter square, that means into 10 to the minus 6 to make it meter. So, this is the FM, FM value will become this. So, the resultant value FR will become FA square by plus FM square, because both are acting perpendicular to each other. So, we can find out FA will be the 4 number of rivets. So, P2 by 4, if P2 is the permissible load. So, this is FA, and FM will be P2 into 0.05 into 0.075 by 6250 into 10 to the minus 6 2 into this. This is FM, this is FA. So, from this I could find out this is as 0.25 P2 plus 0.3 P2 whole square. So, finally, I am getting 0.39 P2, right, and this has to be equal to the rivet value. Rivet value in double shear is 72.6 kilonewton. So, from this I can find out the P2 value, which is becoming 72.6 by 0.39. So, 185.9 kilonewton. So, the permissible load in the joint between the angle and bracket is becoming 185.9 kilonewton, right. So, this is another. So, next will be the connection between bracket and column. So, third one will be connection between bracket and column. So, connection between bracket and column, if we see, so what we will get? First, if we see the diagram, there are 4 number of rivets in each row, it is there. So, we have to find out if P3 is the value, then we have to find out the resultant coming for a particular rivet. So, 4 number of rivets are there in each row, and so this distance are also given. Okay. So, first we will find out m is equal to P into E. So, moment coming to the bracket is, say P3, if we consider the permissible value on this joint is, if it is P3, then P3 into 250 mm, that means 0.25 meter. So, this is the moment, that means 0.25 P3, say kilonewton meter. Okay, if P3 is given in kilonewton. Now, R1 will become 90 square plus 60 square, because you see the distance has been given, these are all 60. So, this is 30, this is 60. So, this total will be 90 and these distance are 60 again. So, this is, if we say this is R1 and if this is R2, then R1 square is this is becoming R1 is equal to 108.2 mm. Similarly, R2 can be find out from this will be 30 plus 60 is equal to 67.1 millimeter. So, if we see summation R square, that will be 4 similar, this rivet, this rivet, this rivet, this rivet will be same. So, 4 into 67.1 square plus 108.2 square. So, this will be the summation of R square. That means, this is becoming summation of R square will be coming as 64838.6 millimeter square. So, summation R square can be found from this formula. Okay. Now, force developed in extreme fiber, force developed in extreme fiber, this will become mr by summation R square. That means, m is 0.25 P3 into, sorry, this summation will not be here, mr by summation R square. So, P3 into R will become maximum distance is this one, and the maximum force will be exerted in this rivet, the outermost rivet, either here or in this rivet. Okay. So, R1 is 108.2. So, we can make 0.1082, this is in meter, by summation R square 64838.6 into 10 to the minus 6 meter square if we want to make. So, after calculating this, we will get as 0.417 P3, right. So, force developed in extreme fiber due to moment is this much, and force developed in each rivet is due to direct force in each rivet due to direct force is equal to P by N. This will be the P by N. P by N means P3 by N, because P3 is the permissible load in case of joint, means case 3. So, here FA will become P3 by N is 8, total number of rivets have been given 8. So, this will become 0.125 P3. So, one is vertically FA which is 0.125 P3, another is from because of moment this at 90 degree angle to this radius, this is Fm, and these values are Fm we got 0.417 P3, Fm we got 0.417 P3. So, Fa we got and Fm we got. Now, we can find out the resultant. To find out the resultant we have to know the angle. So, we know this angle will be theta will become tan inverse 90 by 60, because this distance is 60 and here one rivet at 30 and this is 60. So, total is 90. So, 90 by 60. So, this is becoming theta is becoming 56.3 degree. So, if this is theta, this will become 90 minus theta. So, again as this is totally 90, so this will become theta. So, this is coming theta. So, resultant force Fr can we find out now? Resultant force will be Fa square plus Fm square plus 2 Fa Fm into cos theta. So, from this formula we can find out the resultant force in extreme rivet. So, resultant force in extreme rivet, that means we can write as Fr will become Fa square means 0.125 P3 square plus Fm square, that means 0.417 P3 square plus 2 into 0.417 P3 into 0.125 P3 into cos 56.3. So, from this calculation finally we will get this as 0.5 P3. Now, the rivet value in single shear this will become 36.3 as we have calculated earlier. So, this should not exceed, the resultant force should not exceed the rivet value. So, Fr should become R for getting maximum permissible value, that means 0.5 P3 will be equal to rivet value 36.3 kilonewton. So, from this I can find out P3 is equal to 36.3 by 0.5, that means 72.6 kilonewton. So, for 3 type of joint, 3 allowable load we have derived, P1, P2 and P3. P1 we have got from the connection between girder and angle, P2 the permissible load due to the connection between angle and bracket, and P3 is the permissible load due to connection between bracket and column, and in P3 we are getting 72.6 kilonewton, P2 we are getting 185.9 kilonewton, and P1 we are getting 217.8 kilonewton. That means, if we apply 217.8 kilonewton, the joint which has been made between girder and angle can be taken care, but this cannot take, because the joint between angle and bracket can take maximum 185.9 kilonewton. So, this will fail if we apply this one, as well as this joint is also going to fail. This joint means connection between bracket and column. So, the least of these 3 we have to consider as a permissible load. That means, if we use 72.6 kilonewton as permissible load, that means this can be withstood by this joint, that means joint between bracket and column as well as other joint. So, the permissible load means maximum allowable load will be what? So, P is basically list of P1, P2, P3. So, this is coming 72.6 kilonewton. Okay. So, in this way we can find out that allowable load on this connection is coming 72.6 kilonewton, and we can say the weakest connection is the joint between angle and bracket. Weakest connection is between bracket and column, right. So, first failure will happen here, after that the second, that means the connection between angle and bracket, and then the strongest connection is connection between girder and angle. So, in this way you can make it. So, when we are going to connect a joint through different way, that means a system of members which has been connected through bracket, angle and girders, we have to see which one is the weakest, and the maximum allowable load will be based on that weakest connections. On that way we have to make it. Now, I will go through, means we will discuss about the design of bolted connection. As we have discussed that bolted connection is nothing but similar to the riveted connection. So, just I will give a small overview of this. That means, we will design another joint, means same problem whichever we have done for riveted connections, we will design through the bolted connections. So, let us see that design the previous joint as bolted connection. Previous joint means same values we will take, that is force is 225 kilonewton with eccentricity is 160 mm and 10 mm bracket has been used. We have to design the joint using the bolt. Okay. So, let us see the same connections which have been designed by using rivet, let us see how we will make through bolted connection. So, given things are that direct load has been given to 225 kilonewton and eccentricity has been given as 160 mm or 0.16 meter. Then moment can be calculated from the formula that m is equal to P into E. That means 225 is P the load and E is 0.16, 160 mm or 0.16 meter. So, multiplying these two we are getting 36 kilonewton meter. So, moment we are getting as 36 kilonewton meter, and here we are seeing that the load is lying in the plane of the bolted joint, load is lying in the plane of the bolted joint. So, calculation will be similar, exactly similar to that of riveted joint with the similar case, that load lying in the plane of joint. So, what we will do? Now, we have to assume some number of bolts. That is difficult to exactly decide what should be the number of bolts. It depends how much depth is available, means how much depth we can have here. So, if we have more we can take accordingly, if we have less then we have to make accordingly, means rivet diameter can be made more if this is less, because number of rivets will be less in that case, sorry, the number of bolt will be less. So, if we increase the diameter of bolt, then this number of bolt will be less and as well as the depth of this bracket will be less. Now, as earlier cases we have used 2 rows with 8 number in each row rivets. So, let us use the same, that means 2 rows we will use and 8 number of bolts will be used, and similarly we will provide pitch as 2.5D, that means 50 mm. Okay. Of course, D we do not know here, we do not know the diameter of bolt, and the number. So, to start with, what we are doing, that we are assuming some number and assuming some pitch, and accordingly we are trying to find out the other details. That means we have 8 numbers. So, that means 8 numbers we have bolt. So, the CG will be here, 8 numbers again will be here. So, R1, R2, R3, R4 can be find out. R1 will be what? This one is R1, that means this is 60 as we have assumed, and this is will become 25. So, root over 25 square plus 60 square, which will become 65. So, this is R1 is becoming 65. Similarly, R2 can be made 25 plus this is again 50, as pitch has been considered as 50. So, this will become 75. So, 75 square plus 60 square, this will become R2. So, R2 will become 70 root over 75 square plus 60 square, that means which is coming 96.05 millimeter. Similarly, R3 can be find out as this will become more another 50. So, this will become 125. So, 125 plus 60 means root over 125 square plus 60 square, this is becoming 138.65 millimeter. Similarly, R4 will become this one, this is R4, that means another 50 will come. So, this will become 175 total, 175, and because of 175 the R4 will become root over 175 square plus 60 square. So, this is becoming after calculation 185. Now, so summation R square will become R1 square plus R2 square plus R3 square into 4 times, because similarly at the bottom it will be, and at the left side also 4 numbers will be. So, 4 into R1 square plus R2 square plus R3 square plus R4 square. So, this is becoming 267,598. After calculation we are getting summation R square as 267,598 millimeter square. So, now we will find out the force at the extreme rivet, So, here we have seen which one will be the extreme one, let us see. So, this is the CG, right. Now, this is not rivet, this will be bolt, we will say force at the extreme bolt. So, we know for this type of connection basically Fm varies with R, that means more the distance Fm will be more, because you see if we see the equation, Fm is equal to mr by summation R square. Now, m is fixed, m is constant, summation R square is constant. So, we have R, means R, if R is more then Fm will be more. So, at the extreme point this will be more, that means here it will be more, either here means or at the bottom here or at the left side. So, Fm will become this one 24.9 kilonewton, because m is 36 into 10 to the 6 Newton millimeter, and r is the distance, which is the maximum distance is 185 r4, and summation r square we have calculated. So, from this we can calculate that Fm as 24.9 kilonewton, right. Now, similarly we can find out the axial force. Axial force means axial force exerting in each rivet, that will be simply Fa is equal to P by N. In case of each bolt also this will be P by N. So, 225 is the forces and 16 number of bolt has been used. So, total is coming 14.06 kilonewton. So, 14.06 kilonewton is coming the axial force in each rivet, and theta means the angle between these two. So, theta will be becoming tan inverse 175 by 60, that means 71 degree, right. And as we have seen that if we have rivets, say extreme rivets are here, we have seen that because of the direction of force due to moment is perpendicular to the radial direction. So, this rivet will be becoming the maximum force, or this rivet here it will be like this is 90 degree, but in this case as we have shown earlier, this will be like this and this will be like this. So, here resultant force will be less. Similarly, here also resultant force will be less, because one is nullifying others. So, the maximum forces exerted will be either here or here. So, that can be find out from this equation, that is Fa square plus Fm square plus 2 Fa Fm cos theta is equal to this one, 32.3 kilonewton. So, resultant force we get. Now, what we will do? Now, the new things for bolt will come. In the bolt we know the equation that P is equal to mu n by F into T, where P is the load on a bolt, and in this case means load on a bolt in CR basically. This case it will be 32.3, because this much load has to be carried by the bolt. So, 32.3 kilonewton is the P, and F we know in case of bolt F is factor of safety, and we generally take in case of bolted connection this is 1.4, factor of safety is 1.4, and mu is nothing but the slip factor. So, this we used to consider as 0.45 unless it is mentioned. So, mu value we know, F, so F we know, mu we know. Now, n is the number of interface, and this will be 1. In this case number of interface is only 1. So, with all this we can find out the value of T. T means T is the basically we can say clamping force induced by bolt, which should be less than or equal to proof load. That means maximum permissible load. Right. So, maximum permissible load in bolt which is basically specified in the code. Right. So, we can find out now the value. So, T is equal to we are getting now P f by mu into n. So, P is the resultant force which is exerting on the extreme bolt, that is 32.3 kilonewton. F is the factor of safety, that is 1.4, and mu is the slip factor, that is 0.45, and N is the number of interface, which is 1. So, after calculating this, we are going to get it as 100.5 kilonewton. So, the clamping force induced by the bolt is 100.5 kilonewton. Now, we will see the bolt is taking 100.5 kilonewton. From the codal provisions, now we have to find out which bolt with what diameter can be taken that much. So, we can use from the code, we can see that use HTFG high tensile friction grip M16 bolt, which is taking the value more than 100.5 kilonewton. So, the 16 mm diameter of bolt has been used, HTFG M16 bolt. So, what we have seen in case of bolt design, the difference is the how to choose the diameter of bolt and how to choose the number of bolts. In case of rivet, you can choose diameter of rivet, then we can find out the number of rivets, but in case of bolt, first we will be assuming the number of bolts. After assuming the number of bolts only, we will be able to find out what should be the diameter of the bolt. So, in case of rivet, first we are going to find the number of rivet and then we are going to design. Some approximate number of rivet we are going to find, then accordingly we are going to design and we are going to specify. And in case of bolt, first you have to assume and then you design, means you assume some pitch, you assume some edge, number of bolts, then you will find out the value of T, that means the maximum permissible load which is coming, and accordingly which diameter of bolt can be taken that much load, that can be find out. So, in this way you can make. In next lecture, we will see the riveted connections with load perpendicular to the plane of joint. Today we have discussed mainly on load, means basically the load which is acting in the plane of the connections, using bolted connections, using riveted connections. So, in next class we will focus the same type of, means in with rivet joint, but the load will be in the perpendicular to the plane of joint. Then we will see how to design and how to analysis. Thank you.